Okay, good morning. Welcome to
SuperMath123a.
124a. So we were looking at a bit of the section on triangle inequality today, and I wanted to show you a really cool triangle inequality problem, just because the problems in the book are pretty standard triangle inequality problems, but here's an amazing one. And this is from kind of far down the road in math. This is geometric probability, but I think it's a fun problem to show you. So you break a stick into three pieces. So you have a stick of length 1. If you break it into three pieces, what is the probability that the pieces form a triangle? Okay. And we talked about this already, but so tell me what your initial thoughts were about this problem.
Well, I broke it into 5 cases.
Okay.
So case 1 was where you got an equilateral triangle.
Reach a little more over here. Just to get it on camera.
So case 1 was where you got an equilateral triangle.
Okay.
And there's only one case in there.
Alright.
Case 2 was where you got 2 segments of equal length and another segment, and you could make a triangle.
Okay.
Case 3 was where you got 2 segments of equal length, but you couldn't make a triangle.
Alright. You could not make a triangle.
Case 4 was where you got 3 segments of unequal length, but you could make a triangle.
But you could make a triangle, okay.
And case 5 was where you got 3 segments of unequal length, but you couldn't make a triangle.
Okay. And that's actually a very interesting way to start off on this problem, because that is how you might do a probability problem about balls and boxes, and you're picking balls and you divide it into cases and you see what happens. So that's not a bad way to start. And so what did you think the answer to the probability question was going to be?
Well, this one there's only one case, and then the rest of these there's a lot of them.
How many?
There's infinity.
There's infinitely many cases in these ones. Okay.
So this one is probably not going to matter.
Alright, so that's interesting, because 1 is a small number compared to infinity.
So
it probably doesn't matter, okay?
This one here and this one here were the ones I said could make triangles.
Okay.
And then these 2 were the ones I said couldn't make triangles.
Alright.
So I went with 1/2.
You went with 1/2. Okay. And that's not a bad reason. Infinitely many, infinitely many, infinitely many, infinitely many. 2 work, 2 don't. So 1/2 seems perfectly reasonable.
Mm-hmm.
Turned out the answer is different than 1/2. And we're going to get into why and the triangle inequality for the next 2 parts, okay?
Alright.
Alright, let's go.